Hello, this is an answer key for the timed Schoology quiz regarding law of sines and law of cosines and applications. So I'm going to work through the problems. One thing you're going to notice, these might not be in the same order you saw them on your quiz. So they're numbered there, but number one might not have been your number one because they randomized the order. So I'm going to go through them. They're all the same problems and numbers, but just be aware it might not be the same order you saw them when you took the actual quiz. Okay, so for this first problem, we have triangle MNR. So draw out a triangle, and we can label it side R, which is 8, side N, which is 11, and then angle M, which is 70 degrees. So we're going to want to use law of cosines because we don't have a side and angle across from each other that we would know both the side and angle for. So we want to find side M, right? It says find M. So that's this side right here, side M. So we're going to have M squared equals 8 squared plus 11 squared minus 2 times 8 times 11 cosine 70. Whatever side we start with, the cosine of that angle is on the opposite end of the law of cosines. So we're going to have m squared equals, and then we can do 8 squared plus 11 squared, and we can combine those right now, but we don't want to do the further subtraction on that next step yet. Minus, then we're going to have 2 times 8 times 11, and that comes out to 176 cosine 70. And you can put that all in your calculator now. I wouldn't say that's too challenging to do. You can do 185 minus 176 cosine 70, and you're going to get about 124 point something. I'm not going to round it yet in terms of putting it in my calculator, but just so you have an idea if you've done things correctly so far, you want to square root this. So you should square root your exact answer. Okay, when you square root that exact answer, you're going to get m comes out to about 11.17. So that would be your answer. Again, wherever you were going to round to here, it says nearest tenth. So I guess we could change that to be the correct answer the way it was intended on the quiz, and 11.2, nearest tenth. Okay. So the next problem here is going to be solving for b. Okay, to the nearest degree. So uppercase B, that's the angle measure. So we're solving for this angle right here. And we have side, side, side given to us. We don't have a single side or angle across from each other. So this is another example of using the law of cosines. So we're going to start with 5 squared equals 9 squared plus 12 squared minus 2 times 9 times 12 cosine B. Okay, we want to start with the 5 squared because that's the side across from the B. If we're solving for angle B, we need to start with the side B there. Okay, so we can then go through and start working S down and simplifying it a little bit. So we're going to have 25 equals, and then we can do 9 squared plus 12 squared, and that comes out to 225 minus 2 times 9 times 12, which is 216 cosine B. And this is a case where you do not want to subtract 225 minus 216. Okay, we need to subtract the 225 on both sides first. So when we do that, to cancel it out, we're going to negative 200 equals negative 216 cosine B. Pay attention to the signs there. There's a negative sign here that comes down with that 216. And now we're going to divide both sides by negative 216. Okay, and so we're going to get negative 200 over negative 216, so it's a 200, equals cosine B. And this is where we need to do the cosine inverse on both sides. So cosine inverse, we're going to do the cosine inverse of negative 200 over negative 216, or you can just do 200 divided by 216, because when you have a negative over a negative, it's going to come out positive, and you'll end up with B is about, it says nearest degree, so 22 degrees. It's 22.19 and goes on. So B is about 22 degrees. And we should expect this to be the smallest angle because it's across from the smallest side. So 22 degrees seems realistic for the smallest angle in that triangle. All right, next one, we're going to have a diagram to draw for this. Prince and Miguel are 2,000 feet apart. So I'm going to draw them. I'm going to label them as P and M. So we have P and M, not another P there. I'll change that up, all right. And M are 2,000 feet apart. Okay, Prince spot Justin at a 40-degree angle. So 40-degree angle, to Justin. Miguel spots him at a 65-degree angle. 65-degree angle. Okay. We want to know how far apart are Prince and Justin. So we're looking for this right here. Prince and Justin. That's our M. Okay. So we could solve for this, doing a couple different things. One thing we can do is we could find the angle measure here where the J is. Okay. We could find this angle right here by doing 40 plus 65 and subtracting it from 180. So 40 minus 105, this is going to be 75 degrees. And now we could write out a law of sines. We'd have 2,000 over sine 75 because we know that angle measure now. And we'd have m over sine 65. We can cross multiply then and get 2,000 sine 65 equals cross multiply here, m sine 75. And we're going to have to divide both sides by sine 75. Divide by sine 75. Cancel that out. And that will be what m is equal to. So we're going to use our calculator here. Make sure you know how to put this in the calculator properly, as I've talked about. I would suggest doing just the numerator and hitting enter and then dividing by sine 75. It's up to you. It comes out to 1,870. It might have said in the directions on the quiz, I don't remember, but 1,876.56. So depending on where it asks to round to, again, that you could round your answer there to figure out about how far apart they are. All right, keep moving on here. So the fourth question here, ships A and B leave port at the same time. Okay, so we have two ships. They leave this point. So they're at this point. This is the port. Ship A. Ship B. I'll put a P for port. Okay, the left port. Okay, making an angle of 60 degrees with each other. So this is our 60 degrees. So they leave and they're making an angle of 60 degrees. How far apart are the ships at the end of 4 hours if the speed of ship A is 70 miles per hour and the speed of ship B is 55 miles per hour? So one thing you want to be careful to do not label the sides as 70 and 55. These sides are distances. To find the distance, we do the rate times the time. So for A, the distance it has traveled is 70 miles per hour times 4 hours. So that's going to be 280. Okay? And then B is 55 times 4. So that's 220. And then we can find out how far apart they are. That's what we're trying to find. I'll put a lowercase p since I had uppercase p for there. You can call it X, whatever you want to know. How far apart are they? So from ship A to ship B, okay, what we're trying to solve here is how far apart is ship A from ship B. That's what we're trying to figure out. So that's what we can solve for here. And we can do that by writing out an equation, in this case using the law of cosines. So we're going to have p squared equals 280 squared plus 220 squared minus 2 times 280, 220, and cosine 60. And you could actually type that all in your calculator in one step if you want. Okay, you do 280 squared plus 220 squared minus 2 times 280, and you could put times or in parentheses, 20 times cosine 60. Okay, however you want to do it. This p squared comes out to about 65,200. Not about, it's exact, 65,200. And then we have to remember to square root that. So don't forget to square root that. So we'll take the square root of that, and p, how far apart they are, is 255. Nearest tenth of a mile, so 0.3. 255.3 miles. Okay. All right, next problem, moving on. From a distance of 45 feet away from a building, the angle of elevation of the top of the building is 52.7 degrees. So let's give ourselves a drawing that we can work with on this one. So we have a building here. I'm going to edit that out. Use the highlighter instead of the pen there. All right, let's try this again. Okay, so we've got a building here. Okay, so this is our building. Just put a couple windows so it looks like a building. Great. Okay, angle of elevation. Okay, from a spot 45 feet away. So 45 feet away, angle of elevation 52.7 degrees. What's the height of the building? So we're trying to find the height of the building here, I'll just call it X, or you call it H, whatever, if you want to remember it's a height, doesn't matter, okay? Building, it's going to be standing straight up, so that's 90. So we can do 90 minus 52.7 to find that other angle up here. This angle right here will be 90 minus 52.7, so that's 37.3 degrees. And we could set up a law of sines now, because we could do 45 over sine 37.3 equals x over sine 52.7. Okay, you could set up SOHCAHTOA here as well if you want. Okay, I'll write that out, even though I'm not going to do it that way. I'm just using law of sines and cosines because I'm thinking that's what most people did. But if you wanted to use SOHCAHTOA, okay, we would have from this 52.7 degrees, this would be the opposite, and this would be the adjacent. So opposite and adjacent is tangent. So I could do tangent 52.7 equals x over 45. You could solve that as well. Doesn't really matter. Again, I'm going to go back to what I have in red, because I think that's probably what most people did to solve it. So we're going to do 45 sine 52.7 equals, then our other cross product, x times sine 37.3. Then I'm going to need to divide by sine 37.3 on both sides. And that's would be x. Okay, the height of the building. So 45 sine 52.7, and then divide that by sine 37.3, and it comes out to about 59.1. It says nearest foot, so 59. So 59 feet. Okay, that'd be about to the nearest foot, 59 feet. All right. Here's a 30, 60, 90 triangle. Important to make sure we're remembering how to work with these as we continue to go forward. Okay, so I'm going to label this as a y. Okay, that's our short leg. The short leg is half the hypotenuse, so half of 1 is half. Okay, and the long leg down here, x, is going to be y times the square root of 3. So 1/2 times the square root of 3, which is the square root of 3 over 2. Okay, so the short leg's half the hypotenuse, then we go from hypotenuse to long leg by multiplying by square root of 3. All right, moving on to number 7 here. An isosceles triangle, okay, has a base angle measure of 12 degrees, so we need to be able to draw this out. So I'm going to do that here. So an isosceles triangle means we have two congruent sides. Okay, base angle measure of 12 degrees, with a leg measure of 17. So 17, the legs are 17 here and here. Okay, so how are we going to work with this? Well, one thing we could do is we could divide this into a right triangle. We're drawing a line straight down here. We could use this right triangle then, okay, where we're trying to find the length of the base. We could solve for this x and then double it if you wanted to do that, okay. Another thing you could do is we could find the vertex angle and set up a law of sines, and I'm going to do it that way. Okay, so if we erase that what we did there to divide it, you don't have to do it that way. I'm just trying to give you another option here, if that might make sense to you. So we could find this angle measure right up here, the vertex angle. So the vertex angle is going to be 180 minus the 12 and minus the 12. So we're going to get 156 degrees. Okay, and we're trying to solve for x, the length of the base. That's our x, length of the base. Okay, so now we can do 17 over sine 12 equals x over sine 156. Side and angle opposite each other is what we can use to set up a law of sines. Okay, so when I cross multiply, you're going to have 17 sine 156 equals x sine 12. We're going to divide by sine 12 on both sides, because that's how we're going to cancel it out to get x by itself. And so now we do 17 sine 156, and we're going to divide that by sine 12, and we get, it says nearest tenth, so 33.3. It's 33.257 or so, 33.3. Okay. All right, moving on to the next problem 8 here. Triangle is side lengths 18, 24, and 15. The measure of the largest angle is blank in degrees. Okay, so if I just draw a quick sketch of a triangle here, and you don't have to make it really accurate or anything like that, okay, I'll just label it ABC. Doesn't really matter. Side lengths 18, 24, and 15. Okay, just so we can see, if we're looking at this, the biggest angle should be across from the biggest side, right? So that'd be like here in this diagram I drew. If I want to find the biggest angle, it's going to be the one across from the 24. I don't care where you put the 24, the angle across from that's going to be the biggest angle. Okay, so I'm going to use the A, B, and C like I have here, but it really doesn't matter what letters you use. Okay, so I'm going to have 24 squared. Because if I'm finding the biggest angle, then the biggest side needs to be one across from that. That's what I would start the law of cosines with. And I'm using law of cosines here because I don't have a single side or angle that I know both the ones opposite each other. And so I'll call it cosine A. If you call it x or whatever you want, it doesn't really matter. The key here is that the angle we're solving for is the one across from the 24. Okay, so now we can start working on simplifying this equation. Okay, so I'm going to get 576, and then I'm going to do 18 squared plus 15 squared, and that's going to be 549. And then I'm going to do 2 times 18 times 15, and that's 540 cosine A. Again, you don't want to subtract here and make it 9 cosine A. That's not going to work. So to solve this, we're going to subtract 549 on both sides. Okay, so we can do 576 minus 549 because we want to cancel it out on this side. Don't forget there's a negative 540 still over there. Okay, and that's going to be 27. So 27 equals negative 540 cosine A, divide by negative 540, divide by negative 540. And then don't forget we're going to have to do the inverse here. So A is the cosine inverse of 27 over negative 540. That negative sign is important, okay? Negative sign is important, so don't forget that. And this comes out to 92.86. I think it said nearest degree, nearest whole degree. So that's about 93 degrees. That'd be your answer, 93 degrees. Okay, and we had one more there to work through, solving this triangle, okay? Triangle DEF. We're trying to solve for all of the missing information. So in this particular problem, the thing we need to solve for first is side f. Okay, we're going to solve for side f first. So we have f squared equals 24 squared plus 25 squared minus 2 times 24 times 25 cosine 98. Okay, and so now, again, you could put this all in your calculator if you want. I'm going to do that. So 24 squared plus 25 squared minus 2 times 24 times 25 times cosine 98. And f squared is about 1368.0077, and it keeps going. You can square root that exact answer, okay? And f is about 36.9865884. Okay, and the problem, there were answer choices that were to the nearest whole number, so it was about 37, right? Depending on where you're going to round to, so about 37. So f is about 37. Okay, then now we can use law of sines. You could keep going and try different methods and things to work out different parts of this problem. At this point, you could solve for angle E or angle D using law of cosines. I prefer to use the law of sines in a case like this now. So I would have 37 over sine 98 equals, let's do 24 over sine E. Doesn't matter. We have to solve for E or D. It doesn't matter which one. Okay. So now I can cross multiply. I get 24 sine 98 equals 37 sine E. And when I divide both sides by 37, don't forget we're going to take the inverse. So E is the sine inverse of 24 sine 98 over 37. Okay? So you need to figure out what that part is first. 24 sine 98 divided by 37, and then take the sine inverse of that answer. And E is about, and it says nearest whole, so it'd be 40 degrees, okay? So if E is about 40 degrees, now to find D, I could just take 180 and subtract the 98 and 40, because I've got two angles of a triangle, so I can subtract from that subtract those two from 180, and I'll have my other angle up there, which is D is about 42 degrees. Again, we're rounding all these, but there would be my three answers, and I solved the triangle. All right, so again, running through those, hopefully if there were some problems you had trouble with during the quiz, or you might know after you've seen those where there was a mistake you might have made here or there, you'll follow up with me if you want some further explanation on any of those, and that should hopefully help you out with understanding some of the different work and answers that we saw on those different problems from the quiz.